All right. Hello, everyone. Oh, dang it. I always start it with all right. Okay. Hello, everyone. My name is Matanshi Shukla. I represent tutoring services here at IB Tech Fort Wayne, and we're going to do a Math 123 Unit 2 practice test right now. And along with math, you can see me for a bunch of other nonsense like biology, chemistry, and physics. So come and hang out if you want to just nerd out about that. I am joined here today by my colleague, just Serena, and I'll let her introduce herself.
Hello, everyone. I'm also a tutor for this class and any classes that involve some writing. So if you're taking English 111 and have some papers coming up, please feel free to see me or other tutor. And we really encourage you to participate in this workshop just like not last week, but 2 weeks ago. Your participation will really help you succeed for this exam when you actually take.
Okay, so without further ado, let's get it started. Um, and man, can you guys believe it's already almost July 2026, man? That's crazy, right? Okay, so number one, we're just gonna go ahead and get this thing started. Directions first, obviously, right? Round all everything to the nearest hundredth, unless it tells us otherwise. Do not round until the final answer. This is just a margin of error thing for your answer. When you input your answers into, I think it's Alex that you guys are using for the most of you. Um, and then show all work, partial credit, that's where it's at. You know, a lot of the times in math exams specifically, partial credit is really where you want to bank on a lot of your points, even if you get the whole question, like the answer wrong, right? And then use a calculator. I am going to be today using this Desmo screen, and I'll pull it up whenever it's appropriate so you guys can do the calculation alongside me. Okay, number one, a wildlife biologist wants to find the average mass of turtles living in a large lake. Answer the following questions. Which units could be used as a unit of measurement? Check everything that applies. Okay, so what units should we be using here? Should we be using hours, milligrams, seconds, grams, or kilograms? What do we think? I like to measure my fish in hours for sure. Wow, nobody? Are we waking up? Do we have coffee? Everybody have coffee? I'll get us started. I could probably measure my fish in milligrams. Yeah, thank you, Alyssa. Yes, absolutely. We've got some milligrams, grams, and kilograms. I can measure the, mass of the turtles. I guess it wasn't fish, it was turtles. Um, but yeah, it's mass, right? So that's what I can do. Which procedure below would be the best way to find the average mass? So, would it be to pick up 20 turtles from the shallow area of the lake and weigh each of them? Would it be to pick 20 turtles from the shallow area of the lake and estimate their masses? Would it be to randomly pick 20 turtles from the entire lake and estimate their masses? Or randomly pick 20 turtles from the entire lake and weigh each of them? What do we think here? Which one's going to give us the best for like the average mass here? And I'll label these. So if you're going to put it in the chat, it can be easy for you. But yeah, participations is where it's at, guys. I'll just sit here and wait. I'm sorry. D. Thank you, Alyssa. Mm-hmm. It's going to be D, right? If I just pick it from the shallow area, that's not going to give me the average mass of all of the turtles, right? There might be a lot of just like smaller, younger turtles in the shallow area. So it's not going to be the best choice. Um, really use process of elimination here. I don't want to estimate their masses regardless because that's not going to help me get an average mass that's accurate, right? I'm just guessing, right? So yes, D is the best option there. Number two, in a bake sale, the number of cupcakes sold by each student was recorded. Use the histogram below to answer the questions. Here is the histogram. On the vertical axes, we have frequency, which is the number of students. On the horizontal axis, we have the number of cupcakes sold, and we have classes here that we can see. Um, it's saying one class is the most frequent. How many students are in this class? So I need to find my most frequent, and it looks like it's this guy. And he has how many? He's got 8. That class has 8. Okay. How many students sold 14 or fewer cupcakes? What do we think here? Maybe I'll zoom out a little bit. It's kicking me in and out. Ivania, I'm sorry. Um, I'm not sure why it would be doing that. Maybe try like actually just signing out and then rejoining.
Yeah.
Maybe that can help. Okay.
Oh, I think Ellie is right. If you check your chat, Ellie, you are actually sending me a direct message, which I am happy to see, but I also want Matanchu to see your answers. So when you
Oh,
hit two, click on everyone in meeting.
nice. Nice. So Ellie's been secretly participating this whole time. Love it. Okay. Yes, no, it's 10. How do I know it's 10? Oh my gosh, this is gonna drive me nuts. Hang on a second, guys. I'm sorry. The mouse is like hanging and it's just like moving. Anyway. Okay, so here's 14 and fewer. So 14 is this class right here. There's a total of 6 there. And fewer is this guy right here. And there's a total of 4 there. 6 plus 4 is 10. Very good. I agree. How do I find the class width? What are we going to do?
Is it largest number minus smallest divided by class the total amount of classes?
So it that is how we find the class width, but that's when they give us the largest, the ending boundary, and when they give us the beginning boundary, right? Um, but here they've already done that part for us. We need to, from this picture, determine what the class width is, meaning how big is it from the beginning to the end of each of these bars. Does that make sense? Your formula is correct, but in a different context. Good. Any thoughts about how we're gonna get the class width here? So I think what we do here is we either go beginning of one to the beginning of the previous, as in beginning of one minus the beginning of the previous. So we can either do a 10 minus a 5, or we can do the end of one and the end of the previous, meaning end of one minus the end of the previous. We could do 14 minus 9. Either way, what's our answer? 5. Very good, right? So I don't care which way you do it. Just remember it's either end minus the before end or beginning minus the before beginning. Okay? Any questions about that? Did I explain that okay? Any comments? Any concerns? And Alyssa, I think we will get a chance to do the formula, so you'll see the difference between the two, okay? And here we are, right? So here's our chance to do that different thing. So notice here they're saying draw the histogram using an initial class boundary of 13.5 and an end class boundary of 48.5 with 5 classes of equal width. This is where I do end boundary minus initial boundary divided by n, where n is equal to what? It's equal to the number of classes I want. Okay? So they gave us an ending boundary of 48.5. They gave us an initial boundary of 13.5. And they're telling us that we want 5 classes. So we're going to do that calculation. And I get 7. Does everybody get 7? Good. So this is why my first is 13.5 and I'm adding 7. Because that plus 7 gives me 20.5. And I add another 7. It gives me 27.5. I add another 7. And where do I end? I end at my ending class boundary. Surprise, surprise, right? So this is a good way to check ourselves before we wreck ourselves. Make sure you're paying attention to that. This one has this filled in. They might not have this filled in for you. You might have to fill these values in, okay? So just remember, we're going to need to add that 7 each time. Then what do we do from here? We just count what the frequency is. Frequency by definition means what? What do we think the word frequency means? Oh, it's how often something happens, Matanchu. Yep, very good. Yes, exactly. It's how often something happens. Frequency means how often something happens. So I want to know how often does a number between 13 and a half and 20 and a half happens in this data set. Okay. So we're gonna count through that, right? Yep, very good. I agree. We're going to look at this data list, and if it's not in order, make sure you put it in order. We're going to need to find how many numbers are in between 13 and a half and 20 and a half. So I count 1 and 2. 22 is beyond that. So here's my first bar. Then how many numbers happen in between 20 and a half and 27 and a half? That's going to be 1, 2, 3. 27 and a half and 34 and a half. That's going to be 1, 2, 3. Okay. Then 1, 2, 3, 4, and 1, 2, 3, 4. Yep. Okay. So this is what my histogram looks like. And you can color it in, I guess, if you wanted to. Any questions on how to draw the histogram? Does that all make sense? I see a thumbs up. Nice. Right on. Okay. So, um, you're probably gonna have to do this on Alex. Okay. Yep. All right. So, number four, a group of 7 students was asked, how many hours did you study last week? Here are their responses. So, this set of numbers is what we care about. It's saying find the mean number of hours. How do I find mean, guys?
Add them all together and divide.
Very good. We're going to add everything. And what are we going to divide by, Alyssa?
The amount of numbers there are.
Good. Divide by the number of numbers. So we're going to do 4 plus 6 plus 7 plus 9 plus 5 plus 8 plus 10. And we're going to divide by 1, 2, 3, 4, 5, 6, 7. They told us that there were 7 students, so we're going to divide by 7. And what do we get? I get 7. Does everybody get 7? I could have done math wrong. I'm a person. I do make mistakes. Great. Thank you for confirming that, Ellie. So I got 7. Number 5, the list contains the number of movies a group of 10 students watched in the past year. Find the median. So how do I find median? What do I do? It's the middle number. What's my step 1?
Put them in order from least to greatest.
Thank you. Put them in order from least to greatest. I see a 2, I see a 3, I see a 4, 5, 6, 7. I see an 8. I see a 9, 10, and a 12. Okay. And then I cross out my ends. And if I have 2 numbers left, I add those and I divide by 2. So we're going to do 6 plus 7. We're going to divide that by 2. That should give us 13 over 2, which is 6.5. If there was just one number in the middle, that would be your answer. Okay? Any questions?
So we shouldn't round it at all.
No, no. And this kind of makes sense, right? We know Ellie said, well, what does median mean? It means in the middle, right? So if I've got 2 numbers left in the middle, what's in between 6 and 7? It can't be 7, isn't it? 7 can't be in between 6 and 7, but 6.5 makes sense that it's in between 6 and 7. Does that make sense? Good, good, good. Okay. Moving right along, if there's no other questions, comments, concerns. You guys are doing pretty good. Am I going too slow? Am I going too slow for y'all? Okay. All right. So here's a list of numbers of people eating food last month. Find the mode. Mode means what? Oh,
The
most frequent.
number we see the most.
That's right. Okay. And we see two fours, two six, two sevens, and I don't see anything else that is bigger than that, right? Or like shows up more than that. So the question that gets asked a bunch is, can you have more than one mode? Absolutely, you can have more than one mode. You just have to use a comma and separate your answer. So we know that four is a mode, six is a mode, and seven is a mode. Okay. All right. Now, weighted averages. Did we all get a chance to finish our projects for the weighted averages for your grade book project? If not, come hang out with us. Okay. Market research company records the number of gallons of juice consumed by 20 families last month. Use the table below to find the mean number of gallons consumed. Round your answer to at least one decimal place. Okay, so this is a weighted average. Before I just start this, do y'all have any ideas about, does somebody just know what you do you want to share? Alyssa says, no thanks. Stop making me participate. Okay. So a weighted average, what we want to do is we want to multiply the number of families and the gallons of juice. So we've got 5 and 2. 5 times 2 is 10. We've got 9 times 3 is 27. We've got 6 times 4 is 24. With me so far? Then we want to add everything that we just got. So we want to add these numbers. Okay. So this is going to give me 4, 5, 6, 61. Okay. And if I take 61, what do I do with that? Well, now I have to divide this by the number of families that I cared about in the first place. So I have to do 61 divided by 20. And when I do that in my calculator, I get 3.05. But they want us to round to what? At least one decimal space. So I don't need both of these decimals. So this is approximately what? What does this round to, guys? Oh, try again, Ellie. Yep, Alyssa is correct. Okay. So 3.1, because this would be the one decimal space. So I draw my fence, I look over my fence. This thing is bigger than or equal to 5, so it rounds to 3.1. Okay. And that kind of makes sense, right? A lot of families drank 3 gallons of juice. All right. So, does it make sense for my answer to be pretty dang close to 3 gallons of juice? Yes, it does. A very similar question to a weighted average that we just did, but with a little bit of a twist. This is going to require us one extra step from what we just did. And that extra step requires us to find the middle of the class. So notice I don't just have one number, I have a class, I have a range of numbers, right? So what I need to do here is I need to find the middle. And how I find the middle is going to be um, initial plus the end divided by 2. So I would do 0 plus 49 divided by 2. That's what I would do here. 0 plus 49 divided by 2. When I do that, I get 24 and a half. Okay, then I would do 50 plus 99 divided by 2. When I do that, I get 74.5. And you might recognize a pattern saying like, oh, I'm just adding 24 and a half to each of the beginning numbers. So if you recognize that, by all means, go for it and just say, well, this number I expect it to be what? 124.5. What do I expect the next one? 174.5. Next one, 224.5. Right? If you recognize that pattern, go for it. But, I do encourage, please don't just willy-nilly do things. Use your calculator, especially if you have the time, right? If you're not in a rush for time on your exam, there's no reason for you to like not just double check yourself, right? And then from here, this was the only extra step we needed to do. We rinse and repeat from the previous problem, which was we multiply all of these things. Okay. So, okay, I'm gonna do 24.5 times 5. And remember, we do add them. So I'm just going to do this all in one go, but you don't have to. Plus 74.5 times 11 plus 124.5 times 13 plus 174.5 times 7 and plus 224.5 times 4. And we're going to divide that by what? By the number of patients that I have. I have 40 patients, and I get 117. Please let me know if you guys get the same thing. Are there any questions about what I did? Did I do a bunch of witchcraft and we just don't want to talk about it? Good. Everything makes sense. So that's our answer, right? So what did we do? We did 24.5 times 5. I'm going to do that a little smaller. Plus 74.5 times 11. plus 124.5 times 13 plus 174.5 times 7 plus 224.5 times 4. And I took all of this and I divided it by 40. Why 40? Because there are 40 families. There were 40 families. Okay, questions, comments, concerns? Falling asleep? Okay, all right. I'm assuming no questions, no comments, no concerns. Moving right along. Number 9. Um, in a survey, students are asked to name their favorite snack brand. Which measure gives the most frequent measured brand? Mean, median, or mode? We already know that. That answer is mode. Mode for most, and that's what most frequent means. Okay. Um, B, a company has 9 weekly salaries. These are the salaries. Which measure should be used to summarize this data? Mean, median, or mode? What do we think here, guys? I want to know from you guys. Should we use mean, median, or mode here?
Is it median?
Okay, tell me why you picked that, Alyssa. I like that answer.
Because it says summarize, and when you would find the middle, which is like, um, I feel like that would be like kind of like a summary,
Okay,
the middle
so
number.
you have, yeah, so you have the right answer because, they all kind of give like some version of the middle, technically. Okay. Um, but we would use the median here because we have an outlier, right? So if I use the mean, this is going to say, like, oh, well, most of the people's salaries are here, but this guy is making bank, which is pushing the median or the average to a higher extent. But that doesn't, it's not real. So we're going to use median because if I use median, that outlier crosses out. Does that make sense? Am I explaining that okay? Good. Good. Okay. So part C. During the past 9 days, Maya received these numbers of text alerts per day. Um, Geez Louise, what is Maya up to? All right. So which measure should be used to summarize the data? Mean, median, or mode? Um, what do we think here for this data set? I think this is a solid mean, right? And don't get trapped by because like, oh, there's two tens here, so it's got to be mode. No, if anything, they already asked us about the mode, right? And I've already chose that, and I've got median in, and maybe mean is the better answer here, right? If I'm going to summarize that data, and I notice also that there are no outliers as well. There's not a willy-nilly wild number to the left of the smallest number or a willy-nilly number that is well way to the right of the largest number. Okay. Number 10. A survey of 1,600 adults find that 34% say they prefer streaming movies at home. Answer the following. What is the margin of error? How do I find margin of error, guys? What do we know about that? Do we know that formula? Anybody want to blurt it out? No, we don't know margin of error.
Is it? I think I only know it's over standard deviation.
Oh, you're okay. That's pretty impressive. But no, that's the wrong thing.
Oh,
But I like where your headspace is at. Okay, so we're thinking in standard DB. So that's for normal distribution curves. That's for probability stuff. But I like where your headspace is at, Alyssa. I do. Ellie, you have any ideas?
Is it something divided by like n or
Yeah,
100?
very good. It's something like that. And it's what it is. It's a plus or minus 100 divided by the square root of n. Where what is n? N is equal to what? What do we think n is?
the 1,600 adults.
Okay, it's the yes, it is that for us. N in general is the number of things I survey. Okay? And for us, it happens to be 1,600 adults. Okay. And what does margin of error really just mean? Why do we have this plus or minus? Well, it means give or take. It's sort of like a give or take, right? Um, we have 34% of people saying something, but there is some wiggle room in between there. That's what margin of error is. 34% of people say that they prefer streaming movies at home, give or take some margin of error percentage. Does that make sense? I'm going to assume yes. Okay, so let's plug this thing in. We have one plus or minus 100 over the square root of 1,600. And um, I think it's 100 over 40. And y'all please help me do this math here, okay? 5 halves, which is 2.5. Did I get that? Is that what we get? 2.5. Right on, right on. Okay, so 2.5%. So what do we do with this 2.5%? It's saying, what is the margin of error? Well, this is the margin of error. This is the 2.5%, and it is rounded to the 10th place. Please pay attention to your instructions. Part B is saying, using your answer from part A, we can be 95% confident that at least what percent of adults prefer streaming movies at home? This is where the give or take comes in. I know that 34% of adults prefer streaming movies at home. So at least will be minus my margin of error, which gives me what? 31.5%. Yeah. Okay. Now, please don't add or subtract to the 95%, guys. Oh my gosh, that would break my heart if that's what happens on the exam, okay? Please be really careful. Read that very carefully. All that 95% is saying to you is that how confident you are. I am 95% confident that at least 31.5% of Americans prefer streaming movies at home. Okay? Questions, comments, concerns? Does this make sense? Okay. Part C is saying we can be 95% confident that at most what percentage of adults prefer streaming movies? Well, same thing. I know that 34% prefer streaming movies, and at most would mean I would add my margin of error, and that gives me my 36.5%. Okay. Just read these questions, the margin of error questions carefully, guys. Don't forget the square root in your calculation. Don't forget the plus or minus means give or take. Okay. Otherwise, I think it's pretty straightforward. Okay. Number 11. Here are the numbers of customers served by a food truck during the past 8 days. Find the range of the data. How do I find the range, guys? This one is easy breezy. Let's get it. How do I find the range of a data set? Subtract the highest by the lowest. Very good. I agree. Yes, very good. That is correct. We want the biggest number minus the smallest every time, right? So what's our biggest number here? I think 61. I'm pretty sure. And the smallest number is 37. 24. Yes? No? Maybe? Oh, it didn't. Sometimes if you do a thumbs up on Zoom, it like does. Never mind. All right, moving on. Number 12. Um, the test scores of students in 4 classes are summarized below. Answer the questions about them. Here's the range and the mean. A, based on the information above, which class has the lowest scores on average? What do we think? Lowest scores on average? A, B, C, or D?
Is it C?
So it is C. Very good. I agree. Yes. Boy, I made that suspenseful. Sorry. Yep, y'all are both correct. Okay. So based on this information, which one has the least variability? What does that mean? Variability is referring to range. And when they're asking for the least variability, we care about the smallest range. So it's going to be D. And it kind of makes sense, right? When we think about variability, I'm thinking variety, right? If I have a lot of options, then I have a high variability, right? If I don't have a whole lot of options, then I don't have a whole lot of variability. Does that make sense?
So to find that, we would just subtract each class. Um,
To find the range?
yeah.
Yeah, range is always big minus small, just like in the previous one, right? But here they gave us the range, right? They told us that the range is 44, the range is 38, the range is 51, the range is 36. That's why it's D. But if they gave you a list of stuff, right? If they gave you, let's say, 2 or 3 lists of numbers and you found the range of everything, and then they asked you, well, which one has the highest variability? It's going to be the one with the bigger range. So just like D is going to be the least variable, we can say that C has the most variability because its range is 51, right? It's the highest range. Does that help?
Yeah. Um, so I don't know if this would apply to every problem, but wouldn't it be easier just to find the highest number and the smallest number? Um, if
Yeah.
they
Are you
give
talking
us,
about the problem that we're on, number 12 here?
yeah, yeah,
Uh, right.
if
I
they
just
give
want,
us the range.
yeah, if they give us the range, that's exactly what you do. You just look for the highest number and the smallest number, depending on what they're asking, right? So I'm beating the dead horse here because I just want y'all to read carefully because they won't always have it in this order. They can give you the mean first and then the range later, right? And then a problem next to it, they can give you the range first and then the mean later. I don't want us to get fixated on just the number and the highest and lowest, but instead I want us to, read it carefully and stuff. Okay. But yes, in this context, yeah, you just find the largest number or the lowest number, and that's it. Good. All right. Number 13. Uh, Here are the ages of 12 office managers. What percentage of these managers are younger than 40? Okay. So the first thing that I want to do is I want to make sure that this list is in order. Well, I guess I don't need to do that here, but I need to figure out how many are actually younger than 40. So it might be helpful to maybe have it in order, but I think it is. Okay. So that's 1, 2, 3, 4 office managers that are younger than 40. Okay. And how many in total office managers is that out of? That's out of 12 total office managers. So that is what? That is one third, which is 0.33 repeating, which is what as a percentage? They're saying what percentage? How do I turn a decimal into a percentage? I multiply by 100. So it should give me 33.3%. Okay. Any questions about how I did that problem? Comments, concerns? Okay. Moving right along.
Wait, can you redo
Yeah.
that? Sorry.
Yeah, no, I can redo that. Okay. So they're asking what percentage of these managers are younger than 40? And what is this list that they gave us? They gave us the ages of 12 office managers. So I needed to find however many of them were younger than 40. That's these guys. And so that's four people. That's four people out of how many? Out of 12 total managers. And then I reduced my fraction. They told me that they wanted a percentage, which is why I multiplied my decimal by 100. And that's how I arrived at 33.3%. Did that help? Good. All right. Number 14. Does serum cholesterol levels in milligram per deciliters, I guess, of 20 individuals are listed below. Find the 25th percentile and the 70th percentile of for these cholesterol levels. Now, this one, yes, this one you have to make sure that this is in order. That should be step one, okay? And I'm pretty sure these are in order. Um, Thank you for doing that, actually, Serena, because boy, that was just like a pain.
No problem.
That was just ridiculous. Because anyway, and I always screwed this one up too. Anyway, so this one is a little bit awkward. It's not as simple as doing this. This one we could just count how many were less than 40, and we could do that out of 12. But here they're giving us the percentile, and they're telling us, well, who is in that? How many are in there? So what we want to find is this number here, right? What I've labeled as 1, 2, 3, or 4. That's what we're trying to accomplish here. Which number is it, the first one, the second one, the third one, so on and so forth, that fits in the 25th percentile? And the way we accomplish this is by the formula that if I want to find a percentile or what percentile it falls in, I do P over 100 times N, where N represents the number of numbers that they gave me. And P represents the percentile that I care about. I care about the 25th percentile, so that's going to be 25 over 100. And I'm multiplying this by what? By N. N is the number of individuals that are listed, which is 20 for us. And when I do this, I get 5. Please double check my math. Now, what does that 5 mean? It means that the fifth number, 1, 2, 3, 4, 5, is what fits in the 25th percentile. Okay. If I went too fast on that, don't sweat it. We're going to do it again for the 70th percentile. Again, when we're finding which percentile or where is the correct percentile located, we have to do the percentile I care about divided by 100 times the number of things that I have. That's going to be 70 because we care about the 70th percentile over 100 times 20. Why 20? Because 20 is the number of numbers they gave me. Okay, and I get 14. Let me know if we agree with that. Please and thank you. Good. Okay. So what does that mean? That means that it's going to be the 14th number in order. So there's 5. That's where we stopped. We're going to go to 6, 7, 8, 9, 10, 11, 12, 13, 14th. Here's my 14th number. It's 236. Okay. Any questions about this? This is a goofy one, guys. Any questions, any comments, any concerns? Are we good on that? Okay. I'm assuming we are. Moving right along. Number 15. A national company ranks its 500 sales representatives by the value of their sales. Mia's sales are at the 78th percentile. Leo's sales are at the 91st percentile. Answer the questions below. Now, this is very much so um, kind of presented just like the one we did. But are we going to need to do the same thing? Well, I don't see a list of numbers, so I can't imagine that they're going to ask me anything about that. But what I can do is I can kind of recognize that anytime I'm dealing with percentiles, I can try to fit that in a normal distribution curve. And when they're telling me that Mia's sales are in the 78th percentile, I know that Mia is somewhere over here to the right of the median. Okay. And Leo's sales are in the 91st percentile. So I know Leo is somewhere over here. Okay. And why am I drawing this? Well, just as a visual aid for myself. And where is the mean? Well, the mean I know is probably somewhere over here. This is probably the mean, right? And it's not going to be a median, it's going to be a mean. Why? Because that's what the average means in a normal distribution idea here. Okay. So, which of the following must be true? In A, Mia's sales were higher in value than Leo's sales. Is that true? A, probably not. And B, it doesn't tell us anything about their value. Oh, I guess it does. But it's so that it's just not true. Okay. Both Mia and Leo had higher sales higher in value than the median. Is this true? Alyssa says this is correct. Okay. So this one says Leo sold exactly 13% more than Mia. Is this true? This is, it seems like it's also true. And it's saying that Mia and Leo were both in the bottom half of all sales representatives. Well, that's just false. So, Alyssa, I noticed that you mentioned both of these things were true, right? A or B and C. Which one do we pick? What's the best answer here?
Maybe B.
So I don't think. What do we think, Serena? Is it B?
Let me see. So,
I don't think
91st.
it's B because it should be the mean, right? Then the average, not the median, unless it's one of those tricky
That's
things.
a
So,
good question. I think, man, I don't remember. I think median is correct.
okay. So we're gonna go with that here, guys. I would really encourage, as far as the explanation on this, to reach out to your instructor and have them kind of explain, the thought process that lets us know what's stopping this middle value here from being a mean instead of a median.
Well, yeah, median makes sense because if it's normally distributed, most values should be in the middle where the median is. So if values are above the middle median, which is, out of 150, then they would be above the median.
Perfect. Okay, so there's Serena's explanation. All right. Okay. Part B. Which statement best interprets Mia's percentile rank? Mia has sales lower in value than about 78% of the sales representatives. Well, that's just not true. Mia had sales higher in value than about 78% of sales representatives. I think that's pretty solid. Okay, so we'll keep that in check. Mia made about 78% of company's total sales. Is that true? I don't think that's true, right? Because it doesn't say anything about the company's total. We don't know anything about the company's total, right? So I don't think that that's a very good thing. Mia had sales higher in value than about 22% of the sales representatives. Well, she had sales higher in value than way more than 22% of the sales representatives. So that's just not a good representation of what Mia's situation is like. So B is the best answer here. Okay. Any questions about that, guys? Okay. Moving right along. Number 16. Okay. The heights of a group of students are modeled in this using this normally distribution shown below. The mean of the distribution is 62.5 inches. So, we can just kind of highlight that real quick and say, all right, here's my mean. That's important information. Okay, the standard deviation is 2.1 inches. That's important information. They're telling us that V is under the highest part of the curve, and U and W are numbers along the axis. Okay, using the same distance from V. Okay, so this is V right here. And let me make this a little bit more clear. This is V. And surprise, surprise, the V is the mean, right? And to the right of my mean, I always have three lines. To the left of my mean, I always have three lines. And each of those lines that get further away from the mean are that many standard deviations away from the mean. So that first line to the right is one standard deviation away from the mean. The second line to the right is two standard deviations away from the mean. And the same is true on the left side. So they're saying find using the empirical rule, where is the shaded region at here? We've got to remember that the empirical rule tells us that, yes, this is my mean. It tells us that the middle 68% is one standard deviation away in either direction from the mean. So this is the middle 68%. Okay. It also tells us that two standard deviations away from the mean is the middle 95%. And it finally tells us that three standard deviations away from the mean looks like a hut. No, I'm just kidding. It is 99.7%. Okay. So when I'm looking at this shaded region, what's my percentage here? Am I in the middle 68%? The middle 95%? Or the middle 99.7%? The 95%, I agree. Okay. It's in the middle 95%. Okay. So that tells me that U is at 58.3. It tells me that V, which is the mean, is at 62.5. It tells me that W, which is the other side of the 95th percentile, is going to be 66.7. Any questions about that? That one's straightforward. Good work, guys. Okay. Number 17. On a statewide test, the mean score was 72 and the standard deviation was 8. The scores were normally distributed. Complete the following statements. Okay. When they don't give you a picture, guys, please take the time to draw one. It takes an extra 30 seconds, and you don't need to be Picasso, I promise. Life will go on. Wow. Maybe a little bit better than what I just did there. Okay. So here's my mean. They're telling me that the mean is 72. We're saying that the standard deviation is 8. So I need 3 lines to the right. And underneath each of those lines, I'm going to add 8 each time. So 72 plus 8 gives me 80. Then it gives me 88. Then I get 96. I get 3 lines to the left. And I subtract 8 each time I go to the left. So I get 64, 56. Wait, did I do that right? Yes. Okay. And 44? No, 48.
Yeah.
Thank you. Tim's arithmetic is off the charts. I know that for sure. So I need to be on my toes. Okay. So, yeah, they want us to find the range that is in the middle 68%. So the middle 68 is one standard deviation away from the mean. That's in between 64 and 80. Okay.
Where did you get 96?
88 plus 8. Is my math wrong there? I don't think so. Right. Each time I added 8. Did I do my math wrong? And each time I go to the left, I have to subtract 8. Okay.
We negative 76%.
Then approximately what percent of students are in between 56 and 88? Well, 56 and 88, that's in between here. That's a total of 2 standard deviations away from the mean. 2 standard deviations away, we know is 95%. Okay? Questions, comments, concerns? Alyssa, did I answer your question?
Yeah, I wasn't here for this, so it's kind of confusing to me.
No, it's pretty gnarly. And do you remember earlier, you mentioned like a formula, and I was like, we're gonna get to that. We're there now. Okay, we're getting there. We're starting to get there now. The next one's gonna do it. Maybe not. Although this one is pretty. It always gets students. Okay, let's read this carefully. Below is a graph of a normal distribution with a mean of 4, a standard deviation of 1.5. So I'm going to just stop real quick. We're going to jot this information down. Mean is 4, standard deviation is 1.5. Okay. The shaded region represents the probability of obtaining a value from this distribution that is in between 2.5 and 5.5. Okay, so they've shaded that region nicely for us, right? It's this area right here. So uh, then they're saying what we want to do is we want to transpose this information onto this thing, which is representing a z-score table chart. So how do I do that? Well, what I like to do, and hopefully this is not too crazy, and let me know if it is, but this is what I like to do. I like to jot down a number line, and they're telling me, and I like to plot it. They're telling me that the mean is 4, so I'll put a 4 in the middle, and they're telling me that the standard deviation is 1.5. So I'm going to add 3 lines to the right, and each time I go to the right, I'm going to add 1.5. So 4 plus 1.5 is 5.5. Then it should be 7. Then it should be 8.5. Okay. And when I go to the left, I have 3 lines to the left of my mean. And each time I go to the left, I subtract my standard deviation, which is 1.5. So 4 minus 1.5 gives me 2.5. Then minus 1.5 again gives me 1. Then minus 1.5 again gives me negative 0.5. Okay. They're telling us that this thing is shaded in between 2.5 and 5.5. 2.5 and 5.5. Well, 4 is my mean.
8%.
Yeah, so it's 68%. It's 1 standard deviation away from my mean. So what do they want us to do here? They want us to take this information and transpose it on a chart whose mean is 0 always, no matter what. And each standard deviation is only being represented by 1. So its standard deviation is 1. So each time I go to the right, I'm adding 1. And each time I go to the left, I'm subtracting 1. Any questions about what I'm doing?
I just have a question just in general for the graph, I guess. Is the percentages always the same? Like the
Correct.
60? Okay. So it's just part of it.
You got it. And
Okay.
that's you're looking for key terms like empirical rules and things like that, okay?
Okay.
Yeah, good question. So, what does it mean to transpose something? Well, it's really tough to fit an entire area of Indiana inside of a piece of paper and give it to folks so that way they know where to go. So, what do? We scale things. Okay? That's what we're doing here. We are scaling this so that way we can model what's actually happening. Well, in the original, I am one standard deviation away from the mean. So in my transposed map, I only want to be one standard deviation away from the mean. And that's what I want to highlight. So I'm going to draw my vertical lines in my graph, and I'm going to shade the region in between. This is what they want you to do here. And I know it can be a real pain when you do it on your homework, okay? But this is what they want you to do. Any questions? We feel good about this. Okay. Number 19. Use a standard normal table or a calculator to complete the following information. Find the area under the standard normal curve to the right of z equals negative 0.84. So here's what we're going to do. We're going to find our z-score table.
Where'd it go?
Sorry, guys, give me a sec. Oh, okay, so we're going to look at our z-score formula sheet. Can everybody see this thing for can we see everything?
Yeah.
Good.
Yeah.
Okay. So what do they want us to do? They want us to find the normal standard curve, the area to the right of z equals negative 0.84. So I'm going to find negative 0.84, which is we're going to go ahead and round that to negative 0.85. Okay, guys? And I get 0.1977. Okay? 0.1977. So what's that mean? That means that is somewhere over here. And it is an area of 0.1977, which is the same thing as 19.77%. And what's that mean? That means that this area to the left of that is the 19.77%. But they don't want that, do they? They want stuff to the right of that. So if I want to find stuff to the right of that, I need to do 1 minus my area, which is going to give me 1 minus 0.1977, which should be 80.23%. Any questions on that? Did I explain that okay? Did we do that okay? Okay. Then their part B, they're saying that they want us to find the area in between negative 1.25 and negative 1.73. We're going to change that negative 1.73 to, I'm sorry, positive 1.73 to positive 1.70. Okay. Um, okay. So let's find negative 1.25 on our z-score table. Negative 1.2. Oh, tartar sauce. Let's make it a negative 1 point.
1056.
I'm sorry, say that again, Tim.
It's 1.25 is 0.1056.
0.1056. Awesome. And what is positive 1.70?
1.70 is 0.9554.
0.9554. Thank you, sir. Okay. So when I have this and they're looking for something in between, and again, it doesn't hurt to just visualize this real quick. This negative z-score is here somewhere. The positive z-score is here somewhere. So, and they want stuff in between. Well, if I want that stuff in between, I can do big area minus small area. And that will always work. So I'm going to do 0.9554 minus 0.1056. And what do I get?
0.0610.
0.0610.
Which is not on the chart, so
Oh, it doesn't need to be on the chart, right? You said point.
0.0610.
I don't think that's right, Tim.
Six, 1, 0.
Let me double check. So we're going to do 0.9554 minus 0.1056.
Oh, 10,
I get
minus something else.
I get 0.8498.
I don't know where I got the 8, the
That's okay.
0.8944.
It's Friday, boss. Okay. So, and please read your instructions really carefully, right? I know we wrote a percentage here, but we would have been docked wrong for that, right? Because what are they saying? Give your answer to 4 decimal spaces. So when they do that, they want the 0.8023. They want the area, not the percentage. They want the area, not the percentage. Okay. Number 20. All right. Last one. We made it. Woo. And then there is additional practice. If you guys are interested, I do encourage that y'all do that. And before your exam, come and hang out with us and have us check your work. Okay.
I'll be over here in a little while. I got a bunch of
Yeah.
homework to do tonight, so I'll be there
Sure.
at 4 o'clock.
All right. We'll be here. So a biologist is studying salmon in a river and estimates their mean length to be 48 centimeters. Assume the lengths are normally distributed with a standard deviation of 6 centimeters. So let me just highlight some of this stuff. Mean is 48. Standard deviation is 6 centimeters. Then they're saying find the percentage of salmon that are longer than 57 centimeters. Give your final answer as 2 decimal spaces. So I know that I'm going to need a percentage, and they told me to make it into a percentage. So let's draw a quick picture. They're telling me that it is normally distributed. So I know that it's going to look like this. They're telling me that the mean is 48. I know that there's always 3 lines to the right of the mean, and each line to the right, I add my standard deviation, which is 6 for us. So this is going to be 54. This is going to be 60. This is going to be 66. And I also know that there are always 3 lines to the left of my mean. And each time I go to the left, I subtract my standard deviation. So to the left of 48 is going to be 48 minus 6, so 42, then 36, then 30. Any questions about my picture? We doing okay? Okay. What's up?
Well, no, that's just reading it out
Oh,
loud. I
sure.
apologize.
Sure. No, don't apologize. You're okay. No sorry needed. Okay.
So
So go ahead.
you go from 48, you go to 54, since that's 57, you go like just a little bit past 54 and start your line there and go over to 66 and add those together, correct? Or no?
Yeah, so I know that 57 is over here somewhere. And again, it doesn't need to be perfect, right? But the idea and the visualization to keep us in a sanity check is important here. That's the idea here, okay? And we want stuff that is longer than that. So I care about all of the stuff to the right of that line. Now, because this doesn't fall nicely on my standard deviation, I have to use a formula. I have to use a z-score formula. Because if I had a z-score that's associated with this number, then I could get my probability and my percentage and then find what is to the right of that. So, how do I find my z-score? Well, z is always going to be equal to the value that I care about minus my mean, all divided by the standard deviation.
So
What's the
it's
value? Go ahead.
so be 57
Uh-huh.
minus 48
Mhm. Divided by?
divided by the number that you come up with between 57 and 66.
What's our standard deviation?
That would be deviation 6.
6. So we're dividing by 6, right? The value they gave us minus the mean divided by the standard deviation. Okay. So when we do that in our calculator, 7 minus 48 divided by 6, I get 1.5. So we're going to go to our z-score chart and we're going to find 1.5. 1.5 is right here and it's 0.9332.
Now we do negative or positive because the positive is on the right hand side, the negative is on the left hand side.
Well, it's definitely positive. We got a positive z-score, right? So we better use the positive.
Right. So the correct answer would be 0.8531.
0.8531
Yes.
for 1.5?
Yes. At least that's
Oh,
what's on your sheet. Okay.
oh. I have 0.9332.
Yeah. I'll show you my sheet when I come to the office, when I come
Yeah,
over to that.
yeah. Use yours, Tim, the one that you have, because I think that's the one that your instructor is going to give you for your exam, right? If I'm not
Okay.
mistaken. Okay. So yeah, if yours is saying which was what again?
It's, I'm sorry. I was wrong. You're right. It's 1.5, correct? It's
Yep.
1.50. So it's 0.9332.
Okay.
I don't know
Okay.
why it's
No,
1.05.
that's okay. Hey, I make mistakes. I'm a human being at the end of the day, and It is what it is. It's okay. I'm honest and humble enough to accept it when I'm wrong.
I'm
Um,
wrong.
yeah, no, it's okay. And it's okay. You're allowed to be wrong. This is the place you want to be wrong, okay? Not on your exam. That's my goal, at least. Okay, so what does this mean? This means that all of this area to the left of our number is equal to this number. But I don't want that information. They're not asking for that information. They're asking for stuff to the right of that number. Well, I've got to know that all of this adds up to one, as in 100%,
1%. Right.
right? So if I want that blue area, I can do 1 minus the yellow area to find the blue area.
So it's
And what,
point
one,
nine three three one.
say that one more time.
0.9331.
0.9331.
No, no, I'm wrong. You're 100. 93.32%.
So that is 93 point. So this is 93.32%, but that's not what they're asking us.
No.
They're asking us what
So
this
you think
area is. So we have to do 1 minus that. What is 1 minus that? If you're doing it as a percent, we're going to need to do 100 minus that. So if it's as a decimal, do 1 minus the area. If you changed it to a percentage, do 100 minus your percentage. And what do we get?
6.68.
Yep, 0.0668.
Yes.
Zero point
Right.
zero six six eight. And again, when they ask for the right, the area to the right, we really want to make sure that we do 1 minus the area, okay? So let's do a quick little like cheat sheet here before I call it, right? So when they want area to the left, or smaller than is something else they can say. Okay. Find the z-score and the corresponding area is the answer. Okay. If they want area to the right, or they can say bigger than, we have to find the z-score and do 1 minus the corresponding area. And that is the answer. Okay. When they want area in between, we want to find big, um, find z-scores, right? And we want to do big z-score minus small z score. Okay, so these are the three different ways that they can ask you to answer the normally distributed curve question. Okay? Any questions, any comments, any concerns? We feel okay. All right. Real quick, before I go ahead and finish this up, don't forget, you guys can schedule tutoring appointments with us if you need to. You can call us at 260-480-4262. You can also visit the website and try and hook up with somebody in the drop-in lab for some math, health science, English, pretty much anything. You can email us if it's on a weekend. Obviously, allow us till the next business day to get back to you if that happens to be the case. And you'll find all that information on our webpage at fwtutoringservices.com. Don't put www, it does not work. Okay? So thank y'all so much. I'm going to save this. And when we send out the link, what I'll do is I'll have this worked copy of my work to send out in your email as well. Okay.